what's happening. So I've got a cue ball moving in this direction, hits a stationary ball here. All right. I think it's the 8 ball, doesn't it say that?
Mm-hmm.
Okay. Now it's going to glance off it. So if I hit it up on the high side here, let's say the white ball is going to go this way. Okay. And then that's going to angle that direction of the 8 ball somewhere down in this direction here. Okay, so that's basically what you're looking at in the question, in which this is V1 for your white ball. The V2 is 0 because it's stationary. That makes this V1 prime, and that makes this V2 prime. Okay, so using your equation, I know that V1 is equal to V1 prime plus V2 prime. We get that aspect of it, right? Conservation of momentum. So far, so good. So what I'm going to do here is something a little bit different. How do I show these two vectors added together? All right. Right now, I've got it tail to tail. So how do I show two vectors that are added together, V1 plus V2? What do I have to do with this vector? You don't remember that?
No. Flip it.
Like,
What do you mean flip it?
Put it on the other side to make
No.
a triangle.
Not, no.
Like attach it to the end of it.
Yes,
so
okay,
we have to
that's
add to
better.
the first one.
To the tip. All right, so I'm going to take the tail of this guy and I'm going to just move it. So I'm going to move this guy right here over to here.
Oh.
That makes V2 prime. Okay, it's on the same direction, same path and everything. And so when I add V1 and V2 prime together, I'm actually solving for that guy right there. That is my V1. That was that happened before. Now, the thing is, in this question, that's going to create a right angle. So that's the most important part of this question. That's why we don't need anything else for it, is because we're going to create a right angle here. So I have V1 prime, I have V1. I need to now find V2 prime. And then I need to find an angle at which it goes off at. Everybody following what I'm doing so far?
Mm-hmm.
Okay. All right. So using your Pythagoras' theorem, you can get V1 subtract V1 squared actually. This squared subtract that squared should equal that squared there. All right. So you have 7 squared minus 4 squared.
5.745.
Right, so my V2 prime, it's moving off at 745 meters per second. Okay, now I need to find an angle. All right, and the angle is going to, I'm going to use, well, realistically.
What's your second function, tan?
Yeah, not tan in this case. Brock, I have this here, that's the side opposite, and that's the hypotenuse. So I'd use second function sine in this case.
Okay. I think I found.
Did you find this guy?
Yeah, I found that one first.
Yeah, that's okay. So if you found that one, I would use cos for it, this over this. Unless you use this. Did you use this number?
Yeah.
Okay, so if you use this number, then you're using 10.
Yeah.
If you use that and that, that's fine too. Either way, you'll end up with it. So it says that it's moving off at 35 degrees. All right. Okay, so that would actually be that angle right there, I think. So when you solved it, did you get 65 degrees on there? Or not 65, 55 degrees.
55.152.
Perfect. That's exactly right. So this would be 55.152. Okay, so again, I'm not concerned about the vectors today. All right, just the momentum, I'm concerned about this right here. But we're doing it anyways. We're going to spend a day doing it just so that we get into a rhythm of it, so that when we get into working energy. Okay, the fourth one, 60 kilogram pole vaulter drops vertically from a height of 4 meters, coming to rest in 0.4 seconds. After his feet touch the ground, what is this momentum just before his feet touch? Okay, so this is actually a question that we're going to see again in work and energy. We can solve this style of question using work and energy formulas. But for this one, we are going to use our old formulas now. The ones that you started physics with. The 5 that deal with it. So I've got V1, I have D. Okay, so that is 4 meters, correct?
Yes.
My acceleration is 9.8 meters per second squared. All right, and what else do I know? Do I know anything else? It comes to rest in, okay, so that's after the fact. That's after it hits the ground. So I don't use this yet. I'm using these 3 things here. So what am I looking for? I'm looking for the momentum just before his feet touch the ground. So I need to find momentum. So what is momentum?
F times C.
That's impulse, which is what we're going to use for the second part. Okay, so that's good.
Yeah.
Momentum, though, is mass times velocity.
Yeah.
Okay, so what I need to do then is I need to find my V2 using this guy right here. Okay, I have V1, I have D, I have A. I need to find V2. So V2 squared is equal to V1 squared plus 2AD. So let's punch that into our calculator. So these formulas are going to be important to us again. In work and energy, we're going to use these formulas to show that we got information right.
8.85.
8.85. Okay. So multiply that by 60 by the mass to find out what the momentum is. Excuse me.
531.
531?
I think so.
Okay. Point. Or is it 531?
263.
Thank you. 263. And that's my kilograms meters per second. So I have that, right? Yeah, on the sheet there, that's okay. Probably rounded. Okay. And then it says, what resultant force acts on him during his deceleration? So now, P is also impulse. That's equal to force times the time. So I'm going to get my force by taking that value of impulse or momentum and dividing it by my time. So you take that value that you just used there, Cameron, and you divide by 0.4.
128.1575.
Divide, not times.
1,328.
Oh, I did, yeah, right, that's fine. 51, not 531.
Okay. And that is newtons. So a little off of what they've got in the book there, right? Okay. Are we okay? Yeah. All right. All right, I want to look at, I'm going to skip the next one and I'm going to go to the bottom one. Lab car A, a mass 1.5 kg is traveling east at 2 meters per second when it collides with lab car B of mass 2 kilograms traveling west at 1 meters per second. Okay. So V1 is 1.5 times 2, 3 kilograms meters per second traveling east. V2 is 2 kilograms meters per second traveling west. P. This should be P, right? Thank you. P1, P2. Thanks. Multiplying those together. Okay. After the collision, car A rebounds with a velocity of 0.5 meters per second. So P1 prime then is 0.5 times 1.5. All right. So that's 0.75 kilograms meters per second. In which direction is it going?
It'll still be going east.
No,
West,
it-
it like hit it and then goes back.
Rebound.
It says it rebounded.
Oh, so maybe it was the other way.
Oh, okay, yeah, so it's negative 0.5.
right? So it's gonna go opposite the direction it was going.
Yeah.
So I've got it as west. And then it wants us to find P2 prime now. Okay, so far so good. So the whole catch in that question then is the directions. So to do this, I have P1 plus P2 equals P1 prime plus P2 prime. So I have 3 plus -2 equals -0.75 plus P2 prime. I put negatives in where the wests are. I make east positive. Put negatives in for the west to make them a negative east. 3 subtract 2 is 1. 1 add 0.75 is 1.75 kilograms meters per second. And what direction is it going?
East.
It's got to be going east because it works out to a positive value. And we said east was positive. Now how do I find out what the velocity of it is? Divide by the mass. And how heavy was this?
2?
2 kg. So 1.75 divided by 2 is,
0.8.
what was it?
875.
875 meters per second east.
He's going east? Like
Yeah.
they hit each other and both bounce back?
No. So here's what's happening here. You got one guy going this way, right, Brock?
Yeah.
That's there. So this is my V1 here, and this is my V2 here, right?
Yeah.
So when they hit, V1 gets knocked that way.
Yeah.
V2 keeps going that way.
Like in hockey, when a bigger guy hits the little guy, they don't bounce back. The one guy goes flying.
I mean, that's a possibility that happens there.
Yeah.
Depends on mass, depends on speed, right? But that's exactly what happens. This guy, when they hit head on, this guy carried on in the same direction he was going, and the other guy bounced backwards. Make sense?
What?
Go ahead.
But P1 was going like after, like P1 prime, after the
Yes.
collision, he was going west.
He was going east to begin with, right?
And then went west, right?
And then he got knocked back west.
And then V2 went in the
P2
same,
was west.
but then P2 prime would be going in the
Oh no, you're right, Brock.
Yeah,
You're 100% correct. That he also rebounded.
I was confused.
No, I understand what you're saying now. You're absolutely right.
I'm just lost.
Good for you.
Right, 'cause they're going
This guy
towards
goes
the-
this way, and then this guy hit and went that way, right?
That's why I
Because he
thought
went
too. I
east.
was just kind
You're just kind of sleeping.
of. No, I.
Yeah,
Okay.
so they're going in the same direction after the fact.
Well, they're both going in the opposite direction they were going to begin with.
Yeah.
They're hitting and falling backwards. Okay? All right, I'm gonna leave you with the 3 questions on the back side of that page, all dealing with this right here. I'm gonna give you one more sheet, but I only want you to focus on the questions that are dealing with these guys here. All right, we don't necessarily need to worry about the vector questions for this today. Tomorrow, I'm gonna go through all the work and energy stuff that we need to go through with you. Yeah.
Would you just be able to go through how you got P1 prime from P1 again?
It gave it to us in the question.
Oh, it did too.
It said that after the collision, car A rebounds with a velocity of 0.5 meters per second.
Oh, so
That's
just use
P1
your
prime.
formula.
Anything else? We're okay? Right on.